Welcome to this lecture on research methodology. Today, we are going to explore the fundamental differences between basic and applied research. Whether you are studying zoology, medicine, or any other science, understanding why we conduct research is just as important as knowing how to conduct it. Let us dive in and see how curiosity and necessity drive human progress. To begin, imagine you are in a kitchen watching two different people work. One person is experimenting with yeast and flour just to understand how gluten forms at a microscopic level. They are not trying to bake a cake for a customer. They simply want to understand the fundamental science of baking. Another person is a professional baker who has a customer complaining that their bread is too dense. They need to figure out exactly how to fix today's recipe to make the customer happy. The first person is driven by curiosity, while the second is driven by an immediate problem. This perfectly illustrates our two types of research. Now that we have a real-world analogy, let us formally define the first type. In the academic and scientific world, basic research, also known as fundamental or pure research, is conducted solely for the purpose of gathering information. It is about building upon existing knowledge. When a zoologist studies a new species, they might not have an immediate commercial objective or a specific real-world problem they are trying to solve. They are simply asking why a phenomenon happens. This type of research is the bedrock of all scientific understanding, driven entirely by the desire to know more about the universe we live in. Contrasting with our previous definition, let us look at the other side of the spectrum. Applied research is designed to solve specific, practical problems of the modern world. Rather than acquiring knowledge just for the sake of knowledge, the goal of the applied researcher is highly targeted. They might be trying to improve the human condition, solve a business crisis, or cure a specific disease. While basic research asks why something happens, applied research asks how we can use that phenomenon to fix our current problem. It is about taking what we know and putting it to work immediately. You might wonder why anyone would spend time and money on basic research if it does not solve an immediate problem. The truth is that basic research builds the foundational bank account of human knowledge. Think of it as a savings account that applied researchers must withdraw from later. Without basic research constantly depositing new facts and theories, applied research would eventually run out of new ideas to apply to real-world problems. Therefore, both types of research are deeply interconnected. You cannot have continuous advancement in society, technology, or medicine without both curiosity-driven discovery and problem-driven application working together. To make this connection even clearer, let us look at a historical example. Decades ago, scientists studying the fundamental properties of quantum mechanics were doing pure basic research. They were just trying to understand subatomic particles, having absolutely no idea that their work would eventually lead to the invention of the MRI machine or the smartphone in your pocket. This perfectly illustrates why we cannot abandon basic research. The theoretical discoveries of today, which might seem completely disconnected from our daily lives, become the foundation for the practical, life-saving miracles of tomorrow. Now that we understand the concepts, let us represent the relationship between basic and applied research using a logical mathematical framework. Here, we have a simple equation. K new equals K old plus delta B. Conceptually, this shows how basic research directly increases the total pool of human knowledge. K new represents the total updated human knowledge. K old is the previously existing knowledge we already had. And delta B represents the new theoretical insights generated by basic research. When delta B increases, the overall database of human understanding becomes larger. It does not solve a problem yet, but it expands the toolkit available to humanity. Before we move on to applied research, let us see this basic research formula with a concrete example. Suppose a university biologist notices a specific species of deep-sea jellyfish that glows in the dark. The given situation is a gap in human knowledge regarding marine biology. The researcher wants to know exactly which proteins cause this bioluminescence. There's no hospital asking for this, just pure scientific curiosity. The steps involve collecting samples, extracting DNA, and isolating the specific proteins responsible for the glow. Finally, they isolate the green fluorescent protein, or PGFP. This specific discovery is our delta B. By isolating this protein, they have added a new puzzle piece to the grand puzzle of biology, increasing our total knowledge. This brings us to the mathematical framework for applied research. How do we use that new knowledge? We represent this with the equation S practical equals a function of K new and A effort. Here, S practical represents a practical solution to a real-world problem. This solution is a function, denoted by F, of the available knowledge, K new, and the applied research effort, A effort. If basic research stops, K new stagnates, making it much harder to find new solutions. But when K new grows, applied researchers have a much larger toolkit. By increasing their applied effort, they can generate tangible solutions that directly impact society. Now that we have our applied formula, let us fast forward a few years and look at an applied research scenario. A team of medical researchers is trying to figure out how cancer cells spread, but they cannot physically see the cells. This is an urgent, practical problem. They search the existing pool of scientific knowledge and find the basic research paper about the glowing jellyfish protein. Their applied effort is to genetically modify the cancer cells to express this exact same glowing protein. The final result is a practical solution, glowing cancer cells that can be easily tracked. This perfectly illustrates how applied research relies entirely on the foundation built by basic research to create practical miracles. Having seen the math and the examples, let us visualize this entire process. On the screen is a flowchart representing the continuous cycle of research. On the far left, we start with basic research, which is curiosity-driven. You can see an arrow flowing from it into a central cylinder, representing the pool of human knowledge. This shows how basic research deposits information. From that pool, an arrow flows to the right into applied research, which is problem-driven. Finally, a downward arrow leads to a starburst, representing practical solutions and technologies. This diagram teaches us that fundamental truths uncovered by basic research are eventually transformed into life-changing technologies by applied research. To wrap up our lecture, let us review the most important ideas we have covered. First, basic research is driven by curiosity and seeks to expand the boundaries of what we know without worrying about immediate usefulness. Second, applied research is driven by necessity and seeks to use existing knowledge to solve specific, urgent problems in our daily lives. Most importantly, remember that they are two sides of the same scientific coin. You have now covered the full topic of basic versus applied research, and you understand how fundamental truths are transformed into life-changing technologies. Keep this cycle in mind as you continue your scientific journey.